In the previous video, we set up a Ubiquiti Dream Machine Pro. If you didn't catch it, check it out here. We set it up with just the default configuration and familiarized ourselves with the management of the device. In this video, we'll configure the network and go over the security features and adopt some devices. My name is Steve, and this is it-alchemy. One of the first things you'll probably want to do after setting up your UDM Pro is hook up all of your devices. In this case, I've connected a Ubiquiti access point so we can have wireless connectivity. As with most Ubiquiti equipment, devices must be adopted before they can be set up and configured. Adoption enrolls the device under management of the UDM Pro and allows it to be controlled. To do this, make sure the device is plugged in and powered on. Something to note here is that the access point that I have plugged in requires power over Ethernet, and while the Special Edition Dream Machine has PoE on its switch port, the Dream Machine Pro does not, so I have it connected using the included PoE injector. Go to the Unified Devices menu, and you should see the devices. Click on Adopt and wait a bit. Once it's adopted, you're ready to go. Since we added an access point, there are new sections of the user interface available related to wireless networks. Take a minute to familiarize yourself with them. After the initial setup of the UDM Pro, we'll have a single VLAN shown here as 192.168.0.0 with a /24 subnet. Since this is the only network so far, by default, all the devices in our smart home will be assigned to this network and all will be able to talk to one another. Although this is a /24 subnet and normally that would provide 255 IP addresses, you'll notice that the available pool of addresses is only 248, and you can see that the range is 6 through 254. This is because the UDM Pro will reserve a block of addresses to be used for the network host address, the broadcast address, and a few others for services provided on the network, such as DHCP. This is what you'll see in most typical home networks using your run-of-the-mill Wi-Fi routers and such, but there are several problems with this setup that makes it less than ideal for a smart home. Now, at first glance, you might think the problem is maybe we'll run out of IP addresses, but except in extreme circumstances, 254 addresses, or in this case 248, is more than enough for most smart homes, and you'll never even hit a quarter of that. The first issue is actually more of a security concern. If every single device on your network is all on the same subnet or VLAN, every device has access to talk to every other device, including your networking equipment. This might seem ideal, but what if there was something on your network you don't want to have access to everything? Namely, can someone plug into a network jack somewhere in your house and get into anything that they want? Could your neighbors sit in their living room and connect to your Wi-Fi and do the same? Secondly, by default, many smart devices have a pre-configured address when they're first set up. Can you guess what that IP address usually is? It's usually some flavor of 192.168. something. If your only network is in this range, it's very likely that a device already has that address and you'll get an IP conflict and the UDM Pro won't know which device to route the traffic to. The last concern is network congestion. Many smart home devices use certain protocols to broadcast traffic all over the network. This is usually for discovery of other devices and such, but if every device on this is on the same network, it can become oversaturated and get bogged down. Think of it kind of like a whole neighborhood standing in the same room and everybody talking all at once. By segmenting our network, we can logically segregate certain devices to their own VLAN. From there, we can configure access policies to restrict what that VLAN can communicate with. This is useful for when you don't want certain devices to be able to talk to other devices. For example, only allowing devices on your guest wireless network to connect to the internet and nothing else. To do this, go ahead and click on the network application and edit the 192.168.0.0 default network. For the host address, we're going to change it to a different IP. Now, you can use whatever network range you like so long as it's a private address range. I prefer to use something in the 10.0.0.0 space because it's easy to type. The second octet can be anything from 1 to 255, but I recommend leaving the third octet at 0. For the fourth octet, it will be the first IP in that range for your network host, so usually 1. In this case, we'll pick 10.20.0.1 and /24. That gives us 254 usable hosts, minus 1 IP for the host, 1 IP for a broadcast, and a few others for services, giving us a network range of 10.20.0.6 through 10.20.0.254 with 249 usable IP addresses. After you apply changes, you'll lose connection to the UDM Pro. This is because we've changed the IP of the network, and the IP address on our laptop we have connected here is no longer valid. You can assign a new IP in the new address space by unplugging your Ethernet cord from your laptop and then plugging it back in. There, now we see we've got a new address of 10.20.0.80. Any other devices you may have connected to the UDM Pro will also need to get new IP, so don't forget to unplug and replug those as well. Let's go ahead and log back into the console. Adding additional VLANs is essentially the same process we did when we modified the default VLAN. Go into the network application and click on New Virtual Network. Let's go ahead and give it an IP address of 10.20.1.1. You can see here that the automatic settings assigned a VLAN ID of 2, since this is the second network we've created. The 10.20.1 network being VLAN 2 might be a little hard to remember, so let's change it to 10.20.2.1. That way the 10.20.2 network is VLAN 2 and 10.20.3 would be VLAN 3 and so on. Next, let's repeat the same process for a guest network and we'll make that 10.20.3.1 and VLAN 3. I've left all the settings default so far, but on the guest network, let's turn network isolation on. This will add a rule to the firewall that prevents traffic from other VLANs. We'll also turn multicast DNS off so IoT and other devices can't broadcast traffic to and from this network. Now that we have that done, let's create a wireless network. Go to the Wi-Fi menu and click Create New. We'll give it a name and a password, and under Network, let's select the wireless VLAN that we created. This will force all clients connecting to that wireless network to land in this new wireless VLAN. Now let's do the same thing, but for a guest wireless network. In this case, we'll set the network to the guest VLAN. We'll also check client device isolation and hit apply. We can now take a look at the policies that were created. You can see that our VLAN 3 guest network has traffic blocked to the other zones. This prevents any devices on the guest network from communicating with other devices on other networks. So now we have a fully functioning UDM Pro with some wired and wireless networks, each with their own VLAN and some basic rules. You can further expand on this by segmenting your network even more. For example, adding an IoT network for smart devices, or a VLAN that doesn't run DHCP and can have only static IP addresses assigned. How about a network that has no internet access and so on? As always, please remember to like this video and subscribe to my channel for more content. I hope you'll see how versatile the UDM Pro can be for controlling the network in your smart home. It does seem a bit more complicated than your typical home network setup, but with a little time and effort, you can build something truly powerful, easy to manage. Thanks for watching.